let's go ahead and wrap this up and then, like I said, actually get into our notes. So, recapping, during fifth period, we talked about solving quadratics by using square roots. So get what is being squared by itself. Again, sometimes that might just be the variable of x. And for today, that's all it's going to be. Tomorrow, though, we're going to start seeing that we've got things inside parentheses that are being squared. So, get that by itself and then determine the number of solutions. Again, here's what I'm going to tell you. Your calculator, when you find two solutions, your calculator is only going to give you one. Okay? What is the square root of 16, ladies and gentlemen? Type that into your calculator for me, please. It's 4, but here's the problem. That's only half of it. What's the other half? Last year we talked about something called the principal square root. And it always meant that it was the positive part of it. When you square root 16, there's two answers. 4 is one of them. Negative 4 is the other. Your calculator is only going to give you one answer. Okay? It's important for you to know that there are two solutions. All right? My fourth period class that I have right before this. We're about 2 days ahead of you guys. Very first problem I gave them today had two solutions. Not a single person got it right. Why? Because they just typed it into their calculator and that's the answer they got. As soon as I said, hey, remember to determine the number of solutions you have, then they went back and they got both of them. But most of them, without asking that question, just think that there's one. Okay? So if x squared is equal to a positive number, we're going to have two solutions. If x squared is equal to 0, we're going to have one solution. Now, we have not seen any of these up until this point, but if x squared is equal to a negative number, this results in a no solution. Okay? We haven't seen that yet because we've only solved by factoring. And when we solve by factoring, we either had one answer or two answers. Okay? Now today we're going to start to see that we also have no solutions. Okay? So that's step number 2. Step number 3, I can't really tell you because it's going to depend on what's inside of that. So I'm just going to kind of wrap it up with this. Find each solution. If there's one, find it. If there's two, find them. If there's no solution, you're done, and it's no solution. Okay? It's kind of like, again, back to this absolute value idea. We add 8, divide by 2. We determine the number of solutions, which in this case would be 2, and then you find them both. Okay? That's what you're going to need to do, is you're going to need to find both solutions, or one solution, or two solutions as we move on. Okay? All right. So let's grab, if we don't already, we're going to go ahead and take a look at section 9.4 here. And we're just going to look at example 1 and 2. There are 6 of each of those. And here's what I'm going to tell you. Today we're keeping the answers nice. Tomorrow the answers aren't going to be nice. All right? If you don't have a calculator and you need one, come up and grab one. But otherwise, if you've got one, you're going to want one of those out as well. All right, so at the top of our notes, that's our step 2 kind of in the book's terminology. Okay? So they say it really, really weird, but if d is greater than 0, then x squared equals d has two solutions. Here's the way I say it. If x squared is positive, it has two solutions. If x squared is 0, it has one. If x squared is negative, it has no solution. That's the way I write it. That's the way your book writes it. Same thing, just two different ways to be able to discuss it. Okay? All right. So let's take a look. Example number 1. Example number 1 is I can't say it's one step, but it's one step to get your squared part by itself. Okay? Example number 2 simply has 2 steps to that process. Okay? But our first objective before, just like when we solved the absolute value equation, you can't look at it right away and say, hey, this is how many solutions I have. Until you get what is being squared by itself, you can't determine the number of solutions. So, Mullen, put you on the spot here today. In example 1a, what am I doing to get x squared by itself? There you go, we got to divide, okay? The 2 that is in this problem is not, it's attached to the x squared, but it's not in parentheses or anything. So where we're going to have to begin problem number 1a is dividing each side by 2, okay? There was no addition or subtraction to get rid of, but we did have multiplication to get rid of, okay? Divide each side by 2. That tells us that x squared now is equal to 8 over 2, which is equal to 4. Okay? Evan, how many solutions should we have? Why? Okay, but that's not what we said. If it's positive, there should be 2. Okay, again, your calculator is only going to give you one of those 2. You need to find them both. Quick question. The inverse operation of multiplication is division. The inverse operation of addition is subtraction, so on and so forth. What's the inverse operation of exponent of 2? How do you undo squaring something? That's what it means to square it. How do you undo that? You need to square root it. Okay, the inverse operation of squaring something is square rooting it. So, we need to square root each side. Now, we didn't square root variables this week. We just did numbers, but we actually did this last year, didn't we? Yes, we did. What's the square root of x squared? It's just x. Now, again, go to your calculator, that's great. What's the square root of 4? 2. But Evan's already pointed out there's 2 solutions here. So what's the other solution? Negative 2. Now, one thing that I also want to expose you to, because when you go to check your answers to tonight's homework tomorrow, this is how you're going to see it written. You can shorthand this. If the answers are the same 2 numbers, but one's positive and one's negative, you can shorthand it just by writing a plus minus sign in front. Okay, I bring this up because the next standard, which we will start to discuss next Tuesday, incorporates the plus minus in it. All the plus minus is telling us is that one of the answers is a positive 2, one of the answers is a negative 2. Now, will we use this all of the time? No, because not all the answers are just going to be opposites. Sometimes you're going to get an answer of 5 and an answer of negative 8. The plus minus can't be incorporated there, okay? The plus minus can be here because the answers are opposites of one another. All right, Lily, 1b, what are we doing to solve for y squared? What's it being multiplied by? Example B, we're multiplying by 2. Okay, we need to add 18. We're going to add 18, we're going to add 18. When we add 18, that's how we undo subtraction, is with addition. We get y squared to be equal to 0. Miles, how many solutions should we have? Should just have 1. Because the squared part is equal to 0, this requires us to have just one solution. Okay? Find that said solution by square rooting each side, because again, that's the inverse operation. And I will tell you, you guys do a pretty good job of showing work, I will say that. Make sure that you show that. You square root at each side. The square root of y squared is y, and the square root of 0 is 0. Why is there only one solution? Because the square root of 0 has only got one solution. There's no such thing as a plus 0 and a minus 0. So that's why this incorporates, or it has, just one solution from here. Okay? Riley, what are we doing to solve for example 1c? We're going to begin by subtracting 13 from each side. When we subtract 13 from each side, that now gives us z squared is equal to a negative 9. Canuck, how many solutions should we have here? What? Why? So we have one solution when it's negative. What did we write into our notes? When the squared part is equal to a negative number, that results in no solution. There's no work to show from here because there's nothing to do beyond this. The squared part was equal to 0, or equal to a negative number. That tells us there's going to be no solution. Now, real quickly here, just so we are aware of it, because I want you to be ready for that. Try typing in the square root of -9 into your calculator. What do you get? It says domain error. What in the world is a domain error? Remember, familiar with this here, domain is what you plug into something, right? And the range is what you get out. Domain error says you plugged in a number that's impossible to do here. If you're going to square root -9, what you're asking the calculator is, what number times itself gives you -9? And there isn't one. We talked about this in great length last year. Okay? Because if I square 3, what's 3 squared? It's 9. What's -3 squared? 9. Am I ever going to get -9 by squaring something? No. That's why your calculator says domain error. Okay? So we're going to put no solution in this particular problem. I am going to throw out a disclaimer. This actually does have a solution, but that waits till you get to Algebra 2. For Algebra 1, this has no solution. I don't want to feed you a line of bull there, because at some point you'll find out that that actually does have a solution. Okay? But for our practical purposes right now, we live in the real world, and I say that because the other world's imaginary, and there's an imaginary solution to this. In the real world, there's no real solution. So if I was being super picky, when I used to teach advanced geometry, I tell my students, no real solution. Because that's true. I'm not going to be that picky. No solution I'm good with. But technically, it is no real solution. Okay? All right. You guys slide down and do the next 3 real quick. Find your solutions, if there are any. And then we'll move on to example number 2 here in a few minutes. Alright, Megan, start us off with example D. What are we going to begin with? Subtract 12 from both sides. Subtract 12, subtract 12. That gives me p squared is equal to 0. Adriana, how many solutions should we have here? 1, because it's equal to 0. Find that one solution by square rooting each side. When we square root 0, we get 0. So my one solution is p is equal to 0. Graceland, where are we starting in example E? We're adding 3. Add 3 to both sides. That tells me that a squared is equal to a -1. Carly, how many solutions should we have? Why? Because a squared is equal to a negative number. So as soon as we see that, as a result, we have no solution. Okay? Back to the beginning. Example F. Molnick, where are we starting? We're going to divide by 3. We divide by 3 on each side, and x squared becomes 9. Evan, how many solutions should we have here? Why? Because it's equal to a positive number, so we're going to square root each side to find each solution. I'm going to continue to use the plus minus, so I'm going to say that this is plus or minus 3. If you want to write out 3 and -3, that's absolutely fine. Okay? Lead's cheap. You've got room on your paper. It's up to you. All right. Now, example number 2, the only difference is this. Some of these are going to be 2-step problems, but none of these are going to turn out to be integer answers. Okay? So we're not going to get answers like 5 or 4 or 3 anymore. This is why we did what we did yesterday, which is simplifying radicals that involve fractions. So Lily, what's the first thing we're going to do in example 2a? Divide by 9. Divide by 9, divide by 9. So I have that m squared is equal to 169 over 9. Now, if this can become a whole number, by all means, go ahead and make it into a whole number. But if it can't, don't change it to a decimal. Please don't. Okay? Leave it just like that. Miles, how many solutions?
2.
Why? Because it's equal to a positive number. Find those two said solutions by square rooting each side. And this looks like what we just did on last night's homework. I am going to expect that all answers are simplified within your square roots. Now, I'm not going to show all the work on this because this is what we practiced yesterday. But the square root of m squared is m. We said we have two solutions because it's a plus or minus. And what is the square root of 169 divided by 9? 13 over 3. There's my solution. Because remember, the square root of fraction, you just square root the top and you square root the bottom. The bottom's already a perfect square, so that's why we wanted to square root it like that. Square root of 169 is also 13. I'm going to throw this out there. If you were to get this in part of your work, you're going to need to reduce this. I chose this because this was a problem on your homework last night. You're going to need to make this plus or minus 2 square roots of 5 over 3. We reduce radicals for that purpose. We're not going to reduce radicals and then not use it. Okay? Briley, example B, what are we doing? Divide each side by 36. That means that x squared is equal to 121 over 36. Kanak, how many solutions? Because it's equal to a positive number. Find those two solutions by square rooting each side. We'd have plus or minus 11 over 6. Now, do you guys have your openers from earlier today somewhere? Hopefully. Flip back to those real quick. Told you we were going to revisit a problem. You guys already did example B today. You solved it by factoring though. The equation that I gave you was this. Remember that one? And what did you do? You factored it. Evan did that problem up on the board. What was our two answers he got? 11 over 6 and negative 11 over 6. What are our two answers we got? 11 over 6 and negative 11 over 6. So here's the first one that we can see can be done in both ways. Notice that in the original one I gave you, you kept the 121 over here because you were trying to factor it, which told you to use the zero product property. Whereas here, we actually wanted the 121 on the other side and then still wanted to divide by 36, so that way we could get the x squared by itself. So there are going to be times where you're going to be able to do problems in more than one method. Okay? You can probably see why I like this method better. This is way less work than what we did right here, than what Evan did on the board when he did problem number 2, which was solved by factoring. But we end up with the same results at the end of the day. Alright, Megan, where are we starting in the letter C at? What's that? What's that? Not adding. Subtracting, there we go, subtract 64. So I've got 49b squared equals a negative 64. Adriana, then what? We'd still need to divide. This is a two-stepper here. You got to divide each side by 49. So now I have b squared equals negative 64 over 49. Now we're ready to ask that all-important question. Graceland, how many solutions? None, because this is a negative number. No solution. Now, I want to talk about this quick, without you moving on, because I know that's what all of you love to do. So stop working ahead. Some people will be like, Mr. Tompkins, can't I just stop here and say this is no solution because it's a negative 64? And what would my answer be? No, you can't. And here's why. What if this would have been a negative 49? Then I would have ended up with a positive, and I would have ended up with two solutions. Until you have what is being squared by itself, you can never say that there's going to be a blank number of solutions. You've got to get rid of any addition and subtraction and multiplication or division before you go any other route along the way. All right. Again, now go ahead and do D, E, and F on your own. We'll come back and compare answers here in a minute. Alright, there should be our three answers. Now I am going to point out that I probably did example E different than what some of you did. How many of you, how many of you subtracted 49 first? That's fine. Then what did you divide by? Okay, now here's what you need to make sure you do. What's the negative divided by negative? So you need to make sure that that fraction becomes a positive 49 over 25, right? If you had a negative and a negative, and then all of a sudden you're like, well, it's no solution because there's a negative, that's going to cause issues. Okay? So, again, when you solve an equation, it doesn't matter what you move to one side or the other. as long as you continue to do it, okay? And I'll be honest, for the last few days, most of what we've always talked about is getting your A value to be positive, right? Because when we factor, we like the A value to be positive. I don't care what my A value is in this problem. Okay, like it's positive, it's negative, it doesn't matter. I'm going to solve by using square roots all the same. Okay, now before I leave you for today and let you work, I want to point something out though. Okay? How many of you think solving by square roots right now is easier than solving by factoring? Okay, be honest. And if you don't like it, you don't like it. I love it because I think it's way quicker. Okay? So then the question becomes, can I do this whenever I want? No. Okay? Told you that each one's got its own limitations. I gave you an example earlier today that you couldn't solve by factoring because it couldn't be factored. Okay? I'm going to go back to, again, one of the openers that you did today. You started solving this equation. I remember right, Briley did this one. This was problem number 1. How many solutions did this have? 2 solutions. My solutions, I believe, were -8 and a +7, if I remember correctly. Okay? This one we solve by factoring because you can factor it. Two numbers that multiply to give you -56. I have to give you one way to do that. Here's the problem. You can't solve this one by using square roots. And you might say, well, why not, Mr. Tompkins? You can get your x squared by itself. Here's what, well, actually, I don't want to tell you. Look at all 12 problems that you've just done and tell me how this problem right here is different than all 12 of those. One huge, significant difference. And it's important for us to know this, so I know when I can and can't use square roots. Carla, be more specific. Exactly. These all, and I'm going to use the values we talked about, A, B's, and C's. All 12 problems that you were given on this opener today, or on our notes, this term was non-existent. Your B value, and we need to get used to when I say B, what I'm talking about. Your B value in all of those problems was 0. And in this problem, your B value is 1. That causes issues. Okay? Trying to solve this, I'm not going to tell you that you can't solve this by using square roots, but you don't have the tools quite yet. And when I say quite, you'll need to wait a couple years for it. This one is one you're going to solve by factoring, or the quadratic formula, which we'll learn about later. Solving by square roots is not going to be something you consider. And I need you to be able to think about this, because by the end of this unit, I want you to be able to determine which method is best. Not just solve this because I told you to. Okay? Would I rather use factoring? Would I rather use square roots? Or, if neither one of those work, I'm going to tell you right now, the last one in my choice is using the quadratic formula. But when I look at solving a quadratic equation, yes, I still solve some of those every once in a while. Square roots first. That's my favorite one. Factoring second, quadratic formula third. That's usually the route that I take. Okay? You're going to be specified which and which, but I do want you to start to think about those things as we move along. Okay, homework for tonight is to charge your laptop, make sure it's ready to go for tomorrow, number 1. And number 2, page 597, numbers 3 through 16.